one of them where you had, it was like an x squared plus 1, and then you had like x minus 3. I think there was a couple of them that wound up like that, where you couldn't factor that any further. That's fine. It's no big deal. Okay. You can't factor that any further because that's just a fully factored form. You can't factor that because you'd be imaginary, so you can't do it. If this was, which we'll look at today, if it had an equals 0 here, then you would have zeros at plus or minus I and 3. Okay, that's kind of what we're heading towards with this stuff today. So, other than that, I'm assuming most of it's pretty easy. So, let's add to it then with some newer stuff. That's easy. What I want to do is look at what's called sum and differences of cubes. Now, this is one of those things that when we factor, just like what we had before, when we had something like this, when I would factor that, is the first term a perfect square? Is the last term a perfect square? Is it subtraction? And you were able to get the special pattern x plus 2, x minus 2. And that's how you would factor that. Well, what changes up now is that you get what is called sums and differences of cubes. That just means you are a third degree polynomial sum. And it's the same kind of idea. What happens is, if you have the first term is cubed, and the second term is a perfect cube. Do you guys know how to check to see if something's a perfect cube? Put it in the calculator, yeah. You take a cube root if you'd like. Now, excuse me, I'm going to write this as the same as this real quick. We okay with that? By doing it that way, you kind of start, it's easier to fill in the pattern. So what happens with the sum and the difference one is that the sum is, it breaks it out to being x plus 2, then it'll be x squared, 4, and then you put between the two of them, bless you. What's that? So what's weird about the sum and the difference ones is that you have alternating signs. So the sum, the first part is positive, obviously. And then as you go to the trinomial part, it's going to be minus plus. So it's kind of weird. It's plus minus plus for the sum. It's minus plus plus for the difference. One of those things you'll get used to seeing. Same deal if it's, let's say, x cubed minus 27. A lot of times the numbers are going to be pretty easy. You'll see 8s, 27s, 64s, 125s. They usually don't get much bigger than that. You might put something together. It might be 8x cubed thrown in the front. 8x cubed. Because that's still a difference in cubes. First term is a perfect cube. It just so happens that its root is 2x. So I do it like this one. Change colors here. Excuse me. That would be your generic, the cube root of both. Square the first term, you get 4x squared. Multiply the two together, and you get 6x. And then square the last term. Yeah. Yep. Yeah, you just multiply the two together. It's one of those special patterns, so it's just another way of factoring stuff out. A lot of times when you have difference in cubes, you'll if you factor it out, you're going to get values that you can get a 0 for, and then you get values you're not going to get a 0 for. So, and that's okay. Excuse me. And My silkman's gone. I'm not moving. I'm just getting coffee. Coffee is good. Let's factor this. Use an X. Just use an X. You know what? Textbooks do it all the time. What they do that because just so that you get accustomed to seeing anything can be a variable. It doesn't matter. You'll notice most of the time that I always use X, just because it's just what's in my brain. But yeah, anytime that they give you weird letters and stuff like that, when you write out the problem, just write it as an X. There's nothing wrong with that. Okay. What's your first rule for factoring? GCF. What do they have in common? A u squared. But what else do they have in common? A 4. Okay. I don't know. Does 4 go into 250? It's yeah. So it'll be a 2 then. You're in the right idea. So if I take out a 2x squared, I'm left with 8x cubed minus 125. And now you're to that difference of cubes. Okay? That's the idea a lot of times. You'll do a GCF, then it'll drop to a sum or a difference of cubes. You see this pretty regularly. Remember that if you write these through, that means this is 2x 180 squared minus 5 cubed. So the 2x and the 5 are what you want to call the A, the B, the factors. So you have 2x cubed. Oops, sorry, 2x squared. Then we have 2x minus 5, 4x squared plus 10x plus 25. Yeah, you'll get used to writing it out. Sums and differences of cubes. It's just one of those. Bless you. It's one of those things they never show you this in regular algebra because you never really work with higher degree polynomials. Aside from maybe just using some GCFs here or there. Bless you. But as you get through here, we'll throw them in every time to time. Again, if anything, in this case, what are your dance moves doing? They're doing something. Yes. What are they doing? Careful. What's the degree of the polynomial? It's a 5th degree polynomial. Yeah. And that's, remember, when you're looking at it, you're always talking about the high degree. So it's a down up. Okay, so it's going to be a down up. Yeah, I just factored it. And I just asked what the tails are doing. Let's try another one. Take a second and factor these two. Higher degree polynomials. Take a second, factor these two upper degree polynomials. Is 81x to the 4th a perfect square? Is 16 a perfect square? Is that a subtraction symbol? All right, so that's a difference of squares. Oh, wait a second. 9x squared, is that a perfect square? Is 4 a perfect square? Is that a subtraction symbol?
Oh my god. Why does this keep happening?
Now, why can't I factor 9x squared plus 4 any further? This is the plus sign. There you go. Okay. Excuse me. What's your first rule of factoring on part B? What's the GCF? 4x squared. If I take out a 4x squared, I get x to the fourth minus 5x squared plus 6. Okay. What times what's positive 6 you add together to get negative 5? 2 and 3. But is it okay? Here's the trick. See how this goes power of 4, power of 2, power of 0, or I'm sorry, power of 1? You can factor it like any other trinomial because it works. It always works. You get 4x squared. We're going to get x squared minus 3, x squared minus 2. You're done. Because neither of those is a perfect square. Now, if you think about it, what are the tails doing on that one? What, the 4x squared? They're both up. It's up, up. Remember, look at the first term, 4x to the 6th. 4x to the 6th is positive, and they're even, so they're up, up. Now, that also tells you that you have zeros at 0, plus or minus root 3, plus or minus root 2. Okay? You would have zeros locating there. Now, when you have a 0 that has a square, if x squared is equal to 0, that means what you have is called the multiplicity of a 0. It's just repeated at the same spot. It's a repeated 0. You just don't write it down twice. So if it's an x squared value and it's equal to 0, you just write down 0 once. Okay. So what happens here, to get real fancy, we know I have a 0 at 0, root 2, root 3, negative root 2, negative root 3. I know my tails are up, up, so basically what this is doing, it's coming down, up, change of direction. It looks like that. Okay. What happens here is that when you have a multiplicity or repeated 0, if you will, it changes direction at that 0. Okay. It changes direction at that 0. So if you throw that in your graphing calculator, which I don't have open, which is weird. Seriously, how many tabs on have open? I know, right? I'll get over it. What was it, 4x squared, or 4x to the 6th? And then it was plus 5x to the 4th? No, I'm sorry, 20x to the 4th? Was it minus or plus? Minus? Minus 20x to the 4th. And then it was plus 24x squared. And if we look at it, so like I said, it changes direction at that 0. So anytime you see a repeated 0, it doesn't have to necessarily be 0. Anytime you see anything that's repeated, it's got that what's called multiplicity. The graph changes direction at that spot. Thought I'd show you something new. Okay, what changes now? Not everything changes, but what changes? What do you have to do at the end? Yeah, you just actually get the zeros. Now, if I were you, as I'm writing this down, bless you, I would be automatically putting it in that descending order and setting it equal to 0. That way I don't have to do it twice. You know, as I'm going through it, I might as well just write it down as I'm working on it. So I have 2x to the 5th. So I would write down 2x to the 5th minus 14x cubed plus 24x, and I set it equal to 0. first rule of factoring is to, what's the GCF? 2x, good. So if I take out a 2x, we get x to the 4th minus 7x squared plus 12. Okay? Excuse me. So in this case, what times what's 12 you add together to get negative 7? Negative 4 and negative 3. Remember, our rule is if these are going down 4, 2, and then nothing, you're fine. You can factor it like you would normally. So we get 2x, x squared minus 4, x squared minus 3 equaling 0. Which, now you're right, one of them is a thing, but since I've set it equal to 0, do I need to do any other mathing as far as factoring is concerned? I don't. I can say that I have zeros at 0, plus or minus 2, and plus or minus root 3. And I'd be done with it, because those are my zeros. If I wanted to continue to factor out the rest of the way, I could write it as 2x, and then I'd have x plus 2, x minus 2, and then I would still have x squared minus 3, but I can't do anything else with that. Since I still have to get the zeros, I might as well set it equal to 0 right then and there, and get your plus minuses. This was 2x to the 5th. What are your tails doing? Down, up. They're down, up. We have them at plus or minus 2. Root 3 is somewhere between 1 and 2. And then we have it at 0. So knowing that your tails are down, up, we know that it has to do something like this. I don't know how far up and down those little wavy curvy thingies go, but I know that the graph has to look like that. Somehow it's going to look something similar to that. You throw it in the graph calculator, you'll see how close you actually get to doing that just by plotting via zeros and tails. Here we go. It's kind of similar. It doesn't have to be perfect, but I know that's what my tails are doing. You get a rough sketch with the plot with zeros. I don't know why I keep forgetting to back out that y equals 3. Yeah. 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 Yep. Do those two. All right. Set it equal to 0. GCF. Okay. Excuse me. From here, well, let's see. We know that we have 3x to the 4th. This becomes x minus 3, x squared plus 3x plus 9. We have multiplicity of zeros, and here, there's 0 4 times, a 3. Now these This guy is going to give you a non-real answer. Okay. So if you have a non-real answer, well, no, you can still graph it. But what's happening is that you have changes of direction that occur above or below the axes. Okay. So what happens here is that we could, if I wanted to go further, if I'm looking for just real solutions, I'm done. Okay. If I ask for all solutions, I'd have to use the quadratic formula. Okay. So I forget off the top of my head if the book says real solutions or all solutions. So let's just err on the side of caution and say, hey, let's look at opposite of b plus or minus square root b squared plus 4ac over 2a. So that gives me negative 3 plus or minus the square root of 9 minus 4 times 1 times 9 all over 2. 9 minus 36 is negative 27. Now, negative 27, well, I can simplify 27 as a square root, can't I? Was it 3, I believe? So then negative 27 would be 3i over 3. If it asks for all solutions and you don't give me the non-real, yes, then you missed parts. Then you're just wasting time. All right. Or you can just read the instructions.
Too much work, man.
Sorry.
Too many things to focus on.
Really?
Yeah, he puts this in his locker.
Oh, yeah.
He started every test, and then it's sometimes at the end.
I'm not that nice. Wait. Yes, I should probably look that up, shouldn't I? Because it snowed, like, recently. Yeah, but it snowed, like, the weekend before. But it goes, you're a flurry. You just give it to me. I gotta look that up. I have that on the sheet. Oops, it didn't work. There we go. This one, pretty quick. This was a grouping one. How do you tell what is what? The big giveaway for when you have to group is when you have 4 parts. If there are 4 parts, it's kind of the dead ringer that you have. You're going to GCF it. Okay. So if I take the GCF out here, I get x cubed. I get x plus 1. Excuse me. Did I write that down wrong? I wonder if it was supposed to be a minus x there. It was supposed to be a minus x? That makes sense. Yeah, it was a minus x. Sorry about that. I wrote that problem down wrong. It's supposed to be minus x. And then we have x cubed minus 1, x plus 1. Now, let's say this one said real solutions. Since this one said real solutions, we have terms now? Yeah, we have terms, which means I can set my terms equal to 0. Now, how do I solve that equation, x cubed minus 1 equals 0? You add 1. And what's the cube root of 1? 1. There is no plus minus for this because it's an odd exponent. When you have an odd exponent, when you take the cube root, the sign doesn't matter. If it was the cube root of negative 8, that just means the answer is negative 2. Negative 2 times negative 2 times negative 2 is negative 8. It works. You don't have to worry about plus minuses with cube roots or any odd exponent. So my real solutions here would have been at 1 and at negative 1. There's still, excuse me, if I did factor that out further, I would have gotten to the point of, x minus 1, x squared plus x plus 1. And then I would have had to have done a quadratic formula here to get imaginary solutions. But let's just say it was just real, and you can do that. Not so bad. Oh, it's factoring, that's fine. I wouldn't go that far. Big kids. Those are all find real number solutions. All right, those are all just find the real number solutions. And I just put them all with setting equal to 0. All right, so that makes it them up with factors. You got to be able to do all of it anyway. Okay? We'll do that one. Why not? All right, I'll put it up here in a second. That way you guys got a PDF file. I already have the PDFs on the calendar. So you guys. I posted up there on the screen. You guys can look at it.